So we've got this question from YouTube and we're asked to find the derivative of the function up top there. And the first thing we notice is that we can't really simplify this. So we've got the x squared and we've got the 2x minus 1 cubed, and they're two separate functions. You don't really want to expand the thing on the right because we've got a cube. It's really difficult. So we're going to assume that they can't be separated, or joined rather. And so it's essentially two things multiplied together. And because we cannot do anything about that, we're going to use something called the product rule. And the product rule asks us to define the left-hand side as u, that's x squared, and the right-hand side as v, which is 2x minus 1 or cubed. Now for the method, which is just a method that's been, you can prove in a different video if you want, but it's a method that we use to deal with such a situation. It requires us to have the derivative of those first two functions. So that would be for u equals x squared, we need to find the derivative u dashed. So I'm going to start using a table to organize where I'm going with this. Let's start with finding the derivative of v. In order to do that, we're going to need to use the chain rule. The chain rule is used here because we have a function inside a function. The 2x minus 1 is the function on the inside. And we'll just work off to the right here in order to give us some space. We define the function inside as u, and I know it's kind of used already, it's a bit naughty, but we'll use it because most people tend to use it with chain rule and it makes them feel familiar. So u is, as we said, 2x minus 1, and we still have the overall function v, but instead this time we don't have 2x minus 1, we've defined that as u, so we're going to write it as u cubed. And I like to use tables. In fact, all of my calculus methods, I show how to do them with tables and no formula. We then find the derivative, u dashed equals 2, which is easier than the other one. This then v dashed, with respect to u of course, is 3u squared. And what we're doing with this is essentially multiplying the bottom two here. So that becomes v dashed equals, so firstly 2 times 3, that's 6, and then u squared. We're going to write that again because v dashed is actually in terms of x. So we replace the u with 2x minus 1 squared, and that's as per the definition we have in the top left box. Right, so we've got the definition of using the chain rule of the side, and now we're going to put it into our product rule box, just like this. And v dashed is just going to be written as it is in there. Squared. Okay, so our next job is to differentiate the u. So u dashed is simply equal to x. So we've got every single component now. So what is this? Well, the product rule, from a formulaic point of view, is called a product rule because it's like a times. So if you draw the times there, like a times sign, these are the multiplications we're going to have to perform. Now this obviously comes from a formula. The formula itself it's very simple. It's if we're multiplying two functions u and v and then we want to find the derivative of them, then we are going to take v and multiply it by the derivative of u and add that to u multiplied by the derivative of v. And what you see here with these two terms is that they both have v and u, but in one they'll have a u dashed with a v, and in the other one they're going to have a u with a v dashed, so it just sort of switches. Let's put this over here because we're not going to use the formula. My visual method here doesn't really need it. As long as we remember that product means multiply, we've got that x in the middle, that's the order we're going to do it. So let's start with the two that we have arrows for, multiplied together. 2x multiplied by the 2x minus 1 cubed. And we're going to add that, we're going to add to that the multiplication of these two, which is the x squared multiplied by 6, so we'll make that 6x squared, 2x minus 1 all squared. And this is essentially it. Obviously we want to tidy it up. Now this is some step that a lot of people miss, especially if they're trying to get a particular answer. We can see that there are some pretty good factors here. Now the whole thing, 2x minus 1 squared, goes in both here, not cubed. We'd also see an x in both, which we could take out, and we could also see a 2 if we were so inclined. So let's go ahead and do that. Let's get the right color, and we have 2. We said we're going to take out an x and the 2x minus 1 all squared. And what's that going to leave us with? Well, if we factorize out like this, it's a division. So in fact that's pretty much what we've got there, except for the 2x minus 1. So that's the one thing that we are going to be left with. Hold on a second. Let's need to add a bracket. So we've got 2x minus 1 is still in there. So after the division by what we took out, we have with that. And what's going to be left if we divide into the next one? We've got our 3, took an x out, so we've still got an x. And then, well, that's it, because 2x minus 1 all squared is divided by itself is 1. Well, I mean, it could be it, but it's not quite it. As you're probably screaming now, you could see this is not the answer that you saw on YouTube. Well, if you look in that bracket to the right, what we have is, well, it's kind of like a superficial. Okay, so, what we'll do is we'll write it again, and essentially when we get to this bracket we can simplify it further, because these two terms are like terms, but as I was saying earlier, these are superficial brackets because everything in those brackets are addition and subtraction, which is essentially just addition, so you could ignore them. They're not really there. So 2x plus 3x is 5x, and then we have the minus 1. And that's how we get to the answer on YouTube. So I think a lot of people, they just forget to simplify. Thanks everyone.